Welcome guys, today I'm going to be going over how to find all the solutions to this polynomial equation on board. So it seems like we have a quartic here because the highest degree is of fourth power and also seems to be in a almost factored way, right? We have x minus 1 times x minus 2, so on, all in parentheses, but what's really ruining it here is the right-hand side of 4x squared. So it doesn't seem like it's very easily factored here. But let's try distributing something and see. Very neat. Notice we distribute the x minus 2 and the x minus 4 brackets like this, and also the x minus 1 and x minus 8 brackets. As the constant term, we'll both get positive 8, because minus 2 and minus 4 is 8, minus 1 times minus 8 is also 8. And from there, maybe we can make some sort of substitution. So let's write that out. I'm going to have x minus 2 times x minus 4, like this distributed, and we're going to open it up in a second, just writing it a bit differently for now. And now if we open it, we get for the minus 2 and minus 4 x squared minus 6x plus 8, and that is times x squared minus 9x, also plus 8. And it would be very nice if we could make a substitution for the x squared and 8 sum for some variable and then solve it. But what's again ruining it here is this x term in the middle and the x term on the right hand side. If we do a substitution, it won't really get us anywhere. However, how do we get rid of this x squared term? It's very simple. We just have to divide both sides by x squared. And something very nice will happen if we do just that. On the right hand side, it makes sense. We're going to get rid of the squares and we're going to have 4. But what's going to happen on the left side? We'll consider it like this. We have our first brackets of x squared minus 6x plus 8, and we divide it just by x. And then we multiply it by our second bracket, x squared minus 9x plus 8, divided again by x. Everything makes sense, right? We're still dividing by x squared on both sides. It's going to be 4 because we got rid of the x squared. This denominator is x squared, and the numerator is still our 2 brackets as we needed. And now if we keep doing that, we get, it seems like, x minus 6 plus 8 over x times x minus 9 plus 8 over x, right? And that is equal to 4. And this is absolutely beautiful, because now we can make a substitution if we just let our x plus 8 over x is equal to arbitrary t variable. We could just plug in t, we solve a quadratic for t, and then we solve another quadratic to find all the x terms. And if you watched my last video, this is also a very similar way how I solved another quartic polynomial equation. So let's move on with this. So we get that t minus 6 times t minus 9 is equal to 4. So now let's solve our 2 quadratics. All right, from here it's very straightforward. We defined our t as x plus 8 over x. We have found a quadratic in terms of t. We can quickly solve this quadratic to find values of t and then find the values of x. So let's quickly do that using our standard quadratic solving methods. So using this, we can open it up real quick. We get t squared minus 6t minus 9t, so 15t, and plus 6 times 9, which is 54. That's equal to 4. Then if we move over 4, we can get t squared minus 15t plus 50 equal to 0. And this is very easily factorable, as you can see. And we have something that adds to the minus 15 and something that multiplies to 50. And that seems like it's going to be t minus 5 times t minus 10. See, if you open it up, you get minus 5t minus 10t in the middle, which is minus 15t, and 50, which is minus 5 times minus 10. This is equal to 0, and therefore t is going to equal 5 and 10. Very nice integer values. So now we know those t values. We can solve for x over here. Let's do 10 first. Let's also convert this x plus 8 over x into a common denominator. So we get x squared plus 8 over x, right? Multiply, cross multiply, and over the denominators multiplied. That's going to equal to our t. And we're going to use first not t, but 10. Okay. That's equal to 10. We get that x squared plus 8 equals to 10x. And in standard form, x squared minus 10x plus 8 is equal to 0. Okay, it doesn't seem like you can factor this very well. Yeah, I don't think so. I don't think you can factor it. So let's just use the discriminant for it. We get that the discriminant is going to be b squared minus 4ac. It's going to be 100 minus 32, so I think 68. And therefore our x's will be minus b plus and or minus root of 68 over 2a. So that's just 5. And root of 68, that's just root of 17 times 4, or 2 roots of 17. So divided by 2, we get plus and minus root of 17. And that's going to be our only real solutions, actually, for this. Because now if we do for t equals 5, we'll get some complex solutions. But we are asked to find all anyway, so let's do that as well. We get that x squared plus 8 over x is equal to our next t value, which is 5. So then x squared plus 8 is equal to 5x. And move over 5x, x squared minus 5x plus 8 is equal to 0. Now, right, again, discriminant is going to be, seems like 25, so b squared minus the same 32, which is going to be, I believe, minus 7. And so our x will be equal to minus b plus and minus root of negative 7 over 2a, which is 5/2 plus or minus I root 7, right? Our complex number I, complex unit. So I root 7 over 2. And those are going to be our 4 solutions to this polynomial equation. First, the real one's going to be 5 plus or minus root of 17. And for the complex one, 5/2 plus or minus I root 7 over 2. And that is it. Remember again, when you're solving such polynomials, to try to use substitution in your favor. Try to divide things by terms you don't want to have in your polynomial so you can simplify them into a solvable quadratic, even a linear equation in some cases. That is it. Thank you for watching.